In this video, we're going to work out the line integral of this surface, along this particular path. So C is defined as this, where C is along this diagonal line. So from -2 to 4. So -2 is right here. So your y-axis is this axis here. Your x-axis is this axis here. And +4 along the x-axis. So this point here is right here. So we are moving along this path. Our particle will move along here. So the line integral is really the area. As you're moving along this particular path, it's really the area underneath the surface. So we are looking for this area underneath the surface. So we've already seen this. So if you want to work in terms of time, the line integral is given by this, and we've already seen this. If you work in terms of time, you will need to make some sort of adjustment, and this adjustment is your speed. We've already done this, we've already justified this, so you might have to track back to one of the earlier videos. Okay, so the line integral is given by this. So let's start again here. We've been given our surface, and our particle needs to move along this particular path. So we need to use our technique of parametric equations to drive the particle along this particular path. Well, if you look at this, if you make x to be t, and then as t ticks away, the y value will be given by this. So your parametric equations will be given by this. What that means is you can drive the particle as time ticks away. You can drive the particle along here, which means you can drive the particle along here. So now translate this into your position vector. So your position vector is given by this, because as time ticks away, the particle is moving like this. So that means you always know the position of the particle as it moves. This is your position vector. As it moves, you always know the precise location of the particle. So this is your position vector. In order to work out the line integral, you need to work out your speed. So from your position vector, if you differentiate it, it will give you your velocity vector. So if you differentiate t, it will be 1. If you differentiate this thing here, it will just be a half. So this is your velocity vector. If you want your speed, you need to find the magnitude of your velocity vector, meaning your speed. So here you've got your velocity vector is 1 across and a half up. So using Pythagoras, you can work out the speed. So if you square this, square 1, square a half, square root the whole thing, and it will then give you this thing here. So this is our speed. So you can put the speed into here, and our integral is from our integral is from, well, as time ticks away, you can see time starts at 0, 1 second, 2 seconds, 3 seconds, 4 seconds. So time varies from 0 to 4 seconds. So our integral is from 0 to 4. So hang on. So our speed is given by this. In terms of time, we are moving from time 0 to time 4. Time 0 to time 4. And then so what that means is, hang on. What that means is, as the particle is moving along here, meaning as the particle is moving along here, once we know this location, we need to put it into the surface to jump to. We need to put it into the surface in order to obtain the height from the ground level to the surface. So as we're moving along, we need to put this location x, some sort of location x and y, into the surface, and then it will jump to the surface. So what that means is this. Hang on. Our x and y location, this is our x location, this is our y location. So we need to put the x and y location into there. So put this into the x, and put this into the y, because as time ticks away the particle is moving along here, meaning we always know the x location and the y location. If we know the x and y location, then we can work out the height of the surface. So so put this into the x, put this into the y. That will then give us this. That will then give us this thing here. This is our x and this is our y. So that this is what is meant by some sort of function to describe our x location. This is some sort of function to describe our y location. In our case, are some sort of location, are some sort of function. In our case, is just t, and then some sort of function. In our case, it's this thing here. Okay. Well, anyway, we are currently here. So our line integral is given by this. Well, this is just a constant, so let's drag it out here. So that will then give us this thing here, and then tidy this thing up. That will then be this, and then if you merge all three into one and then take the reciprocal, it will then give us this thing here. Think about it, from here to here, and then this is just a constant. Take it out, so the two 2's will cancel each other out, giving you this. Now integrate this. It would be the absolute value of t plus 4 from 0 to 4, and then put 4 into here. That would be 8. Put 0 into here. That would be 4. So when you log one thing, take away another thing, that's the same as you getting one thing divided by another. So combining these two would be log 8 divided by 4, which is 2. So the final answer is given by this. So this is the area underneath that surface along that particular path. Okay.